All right, here's the example that we did in class that was similar to the test question you're asking about. So, you are trying to find the absolute minimum and maximum values of this function, and you're doing it over this rectangle here. So you're doing it over the space between x equals 0 and 3. So that's a plane at x equals 0 and a plane at x equals 3. And then also from y equals 0 to y equals 2. All right, and so that's your little area. First you go and do your derivatives, your partial derivatives. You get 2x minus 2y, and fxx will be 2. Fy will be negative 2x plus 2, and fyy will be 0. And over here, fxy will be negative 2. And over here, if you did fyx, you'd also get negative 2, and they're supposed to match. So you need to know when these two pieces equal 0, and that's going to be your critical point. So when does 2x minus 2y equal 0? And also at the same time, negative 2x plus 2 equals 0. So it's like a system of equations. So I can see here I can solve for x right there. So when I solve that for x, I get x equals 1, and I plug that into here, I get y equals 1 as well. So I'm starting off with the point 1, 1, and if I plug 1 and 1 into here, you also get 1. So we check our Hessian matrix. Our Hessian matrix is going to be this number in the top left corner, this number in the bottom right corner, and then these numbers in the other corners. So when I do that, I get 0 minus 4, so I get negative 4. So any point that I find with any critical point that I just found is going to be a saddle. All right, but that's kind of the same as everything else that we've done. So now you have to check the boundaries here. So if you look at a picture of this problem, this is what it looks like. And so what we just found right there, we just found that saddle point right there, right? We just found that point. It was at, oh, you know what? I was like, that doesn't look like 1, 1, 1. Because look, I put the problem in wrong. I put an extra 2. So this should just be x squared, right? There we go. All right, so that looks a little bit, well, it's all like not the right color now. Whatever. All right, so good. That does look like the 0.111 now. All right, so what we're trying to check is that x equals 0. So I'm sorry, we're going to try to check the boundaries, x equals 0 and x equals 3. So I think if I put a plane here of x equals 0, so basically I'm looking for where that plane intersects my graph. So see it, x equals 0 is along the green line. And so if you look at where that blue and that red kind of intersect along the green line, they intersect at a line, so that this line coming down that you see where the blue and the red are intersecting. And then I'm going to look at x equals 3. And I will show you why I'm doing this in a second. All right, so x equals 3. X equals 3 is on the x-axis at 3, so let me get around to it. So right there. All right, so also it's intersecting in a line. So I know it's kind of hard to see, but like where that red and that green intersect, that's a line right there. And so let's go back and check that out. So what we're trying to do is we're trying to let x always be 0, right? Because that's at that point, that's at that plane when x equals 0 crossing this. So I'm going to check my boundary, x equals 0, and I'm just going to check the one x equals 3. All right, so when x equals 0, I can literally put 0 in for x right here because I'm always letting x be 0. So I get my function, I plug 0 in for x, and I still have my regular y's. So if I did that, I would get 2y. And so that was that line that we saw. Okay, and so then if I do x equals 3, well, I'm letting x be 3 right here. And so I get f of 3y. And that would be 9 minus 6y plus 2y. So 9 minus 4y. So that was the equation of that line that we were seeing with the intersection. So what we're doing here, and I'm out of space here. Anyway, I would have written it down here. I'm going to just write it. So this is the line right here, and y, remember, is between 0 and 2. So I only have y left. Oops, that's a 0 and that's a 2, because y is between here and here. So when you have a line, I'm going to continue this part over here. When you have a line and it has a positive slope, you know that the bigger the number you put in, the bigger the answer is going to be, and the smaller number you put in, the smaller it's going to be, right? So if I was to use 0, so I'm using 0 for x and 0 for x, 0 for y, and I'm using, and then that actually gets me, when I plug it back into the full equation, 0. And then at the other end, and lines, you know, it's a positive line, so there's no up or down in it. This is my low, this is my high. So I'm basically just found my low point right there on that line. And when I plug in 2, that's going to be my high point on that line. So if I plug in 0, plug in 2 for y, I end up getting, and I can plug 2 right into there, I would get 4. So that's like a low point and a high point, all right? So we'll take a look at all of them at the end. So do the same thing for here, but it's going to be backwards a little bit because this line right here has a negative slope. So it has a negative slope. So that means that the bigger the number I put in, the smaller answer it's going to be. But we'll just do it. Let's see, we have 3 for x. We're again using 0 for y, so y is between 0 and 2. So if I plug in 3 and 0 into my main equation, I get 9. And then if I do it again with 3, but this time 2, I should get a smaller answer. So when I do 3 and 2 into my main problem right here, I get 1 because it was going down. Okay, so there's some points on my edges. My edge of where the graph is meeting, where this graph is meeting these two planes right here. Okay, all right, so let me get to a new page. So now we're going to do where the graph meets the red lines, the y equals 0 and y equals 2. I guess we'll do it up here. So y equals 0 and y equals 2. So if I let y equals 0, I get x, and I let y be 0 in the main problem, I get the equation x squared. And so if I let y be 0, y be 2, in the main problem, I end up getting x squared minus 4x plus 4. Because the main problem was what? X squared minus 2xy plus 2y. So if I let y be 2, I put a 2 here and a 2 there, I get a quadratic. Okay, so that means that when my shape meets y equals 0, there's a parabola. So the parabola that I'm going to see is this, all right? And that parabola, remember, x is going to be between 0 and 3. So because I know what that parabola looks like, I know that there's a low spot here, and then when x is 3, there's a high spot. So when I go to plug in 0, I would get the point 0 for x, 0 for y, and I already have this point earlier, 0. It's basically like the corner, right? When I go to plug in 3, I have 3, 0, and I already have this point 9. Because what was happening here is that this thing was like totally increasing the whole time right here. So there wasn't anything weird going on in that space. I knew I was going to get a low point and a high point. Because frankly, when I was testing y equals 0, I was testing along here, right? And it was just a constant increase the whole time. So basically these two corners were the only thing that I was going to find important. So nothing weird was happening in the middle. But over here, I have x squared minus 4x plus 4. So when I graph that, or when I think about that when I'm intersecting, this thing, now you can do this one of two ways. You could graph this parabola. Now this parabola does factor into x minus 2 twice. So if you remember your algebra 2, that is a parabola. It's going to cross at 2, and it's going to be bouncing. right? And remember, I'm trying to go from x from 0 to 3. So here's 0, it's bouncing at 2, and then there's 3. And so I do have kind of a special point. So it's going to, so here's that corner, which I would get anyway, but there's a special place at 2, and then it's coming back up to 3. So there's like a low point that I don't want to miss out on, okay? And so I'm going to go ahead and plug in these. I got 0, 2, and that would produce 4. This one, I got 3, 2, and 3 and 2 from earlier produced 1. But there was like a hidden low point, possibly right here, and that's when x was 2. So I want to try 2, 2, and see what I get. Now there's two ways to do this. You could think about the picture, or you could go over here and say, if it's a parabola, when is the parabola going to have a max or a min? So you do its derivative. Well, the derivative of x squared minus 4x plus 4 is 2x minus 4. When does that derivative equal 0? At x equals 2. The place that we knew about anyway, because we could graph this kind of easy. So that's how I find the number in between the interval. If it's in between the interval of 0 and 3 that I'm interested in, then I'm interested in it because something's happening there. All right, so when you plug 2, 2 in, you get 0. Okay, so your job is to summarize this. We want any saddles. We want any minimum and maximums. Oops. And if you want me to show you, let me show you the picture. So if you do y equals 0. All right, so you see when it's intersecting the graph, how you're getting, it looks like a parabola there when it intersects the red and the blue. And if I do y equals, 2? And so y equals 2, when it intersects, you see how it's intersecting at that parabola there. And so that's what I was talking about. Okay. All right, so you just go ahead and then you summarize. We knew we had a saddle earlier at 1, 1, 1. And let's see, my lowest points that I was getting. Look, here was one of them, 2, 2, 0. And I guess 0, 0, 0. 0 was the lowest I was getting, right? Yes. Okay. So actually this point was important. A lot of times it doesn't help a lot, but then you're kind of mad you did all this work. All right. And then the maximum, I think this 9 was probably the biggest. Let me see. Yep, 309. Okay, so just summarize everything there. All right, see you later.